Hey, this is Trixie Hall conducting my interview with
Nyjah.
And Nyjah, you go to
Renaissance.
And what grade are you?
9th grade.
All right. So, I first want to thank you for participating in our assignment, and do know that the work that you're doing today is going to help future teachers.
Mm-hmm.
Okay. So I want to ask you a series of questions, and to the best of your ability, try to work through the problems. I have 6 problems for you.
Mm-hmm.
If we make it through all 6, fine. The interview shouldn't go longer than 45 minutes, okay?
Okay.
All right, so I'm just going to give you a series of questions, and I won't let you pick, so I'm just going to work and see how you do. I won't let you choose. Okay, so the first problem, it has to do with car washing.
Mm-hmm.
Okay, so in this problem, I'll read it out to you. It says that Metro Car Sales hires washers to wash the cars in their lot. The manager knows that 36 washers can wash all the cars in 1 hour. What if only half as many washers worked? How long would it take for 18 washers to wash all the cars?
It would take 18 washers, 30 minutes to wash all the cars.
Okay. Let me tell you the question again. Metro Car Sales hires washers to wash the cars in their lot. The manager knows that 36 washers can wash all the cars in 1 hour. So how long would it take 18 washers?
Okay. So it'll take 18 washers, 2 hours.
Okay. Are you just going off the top of your head? Is there some method that you're using right now, or no? Just
half. I'm saying that if 36 washers wash cars in an hour, so half would take twice as long.
Okay. So how long would it take for 9 washers?
3 hours.
Okay.
Yeah, 3
Okay.
hours.
Okay. And how long would it take 72 washers?
Half an hour.
Half an hour?
Mm-hmm.
Okay. How long would it take 4 washers?
4 washers.
How long did you say take 18 washers? Did you write that down? 18 washers? How long did it take 18 washers?
18 washers. 2 hours.
And how many for 9?
9 washers. 3 hours.
72 washers.
72 washers. It would take 30 minutes.
Okay, and 4 washers.
4 washers. Sure. 4. Okay, so if it was 4.5 washers, it would be there's 4.5 washers. 4 hours. You think?
What are you thinking?
I'm thinking what I did, I cut everything in half pretty much.
You cut
As
everything?
as the washers cut in half, I added an hour every time the washers were cut. So 36 to 18, I added 2 hours because it's half of the people. And when it's in another half, I added 3 hours. Well, I added one more hour. And when it's 72 washers, 36 is 72. So I say 30 minutes because they had double the washers and it would be less time. So 4 washers, I would think it would take 4.5 hours. Well, 4 hours. 4 hours and 30 minutes.
For 4 washers?
For 4 washers.
Okay.
4 hours and 30 minutes.
Okay, so let's say that the manager, she needed help to figure out how many hours it would take to wash the cars for any size group of workers. How would you help the manager figure that out based on the work that you've done? Is there like a certain method she could use to?
She can always divide the number of hours by the person to see how many people it takes to do like this type of job or that job and how many hours. So then she can figure that out.
How would you write that for her? Could you give her a visual as to what she could use?
Sorry.
So this. Go ahead. I'm sorry. Just describe it in words to her how she could figure it out.
She did what I did. I had as the washers number decreased in half, I added an hour.
Okay.
Because I felt like 36 in 1 hour. So if that's half of that, it's gonna take 2 hours. That's just my logic on how to do things. And if it was half of 18, it'd be 3 hours. So I would know how to write that down and write it down in a problem.
So if you had to write an equation,
if I had to write an equation,
what do you think would be in the equation? What do you think would be needed to make the equation so that she could use that?
It would have to be I wouldn't even know how to write that. Would it be 18?
So even if she doesn't know how many workers she's going to have.
Right.
So if she didn't know how many workers she was going to have, how could you write it in the equation to say, well, if you have this number of workers, you can plug this number in and then use this formula to say...
I don't know if a linear equation or a two-step equation work. Let's see. So if she already knows that 36 washes will do an hour.
Right, she knows that.
So 36 equals. Okay, I got it. 36 is the number of people. People.
So how would you represent people in the equation? Are you using 36 as the people or?
As X.
Okay.
So X is equals, oh, no. No, 36 wouldn't. X would be the number of people they have. But I'm trying to get her, I'm trying to teach her how it would be when she already knows this.
Okay, keep writing. I interrupted you. I shouldn't have did that. I'm sorry. So you said 36 was the number of people. So that's how you were starting your equation.
Right.
So
36 was the number of people.
Mm-hmm.
I know it's going to have to equal 1. Okay, 1 is the time it takes. But I wouldn't know what goes in the middle of it. 36 is number of people. 1 is the time it takes, 1 hour. The time it takes.
So when you look at what you've written down, what do you have? What do you have written there? And the problem, what are your variables? What are the 3 things that you're looking at?
I'm looking at the X is supposed to represent the number of people that she supposedly has.
Okay.
Or that she doesn't know that she's going to have in that day. And then 36 is the number of people that she already knows that it takes 1 hour to do the job.
Okay. So X will represent the number of people?
Yes.
Okay. And what else would you use? Think about it. It's nothing hard. Well, I shouldn't say that. Don't feel frustrated and that I'm rushing you. If you need to think, go ahead and think about it. It's no right or wrong. I want to know how you're thinking to develop your answers.
But you don't have a B though. It's not a linear equation. But it's not a regular equation.
You saying it's not a real equation?
No, I said it's not a linear equation. Okay. I'm saying like usually when I do problems, I always go to MXYZ. Even if it's just like a regular problem. Even though if I'm not graphing it, I still go back to that equation. Okay. So I usually go there, and X is the number that's always increasing. So I wouldn't know if it's time or people, because people is increasing no matter how many people you have, and time is increasing no matter how long they can have it takes to do the job.
Okay. Okay, so let's see if we can do this here. It says, so now if you write an equation for finding the number of hours it takes to wash the cars, if you know the number of washers, let H represent the number of hours it takes, and let S represent the number of washers. So could you go from there, lady?
H is what?
H represents the number of hours it takes, and S represents the number of workers. Or washers.
Washers?
Yes.
Is S?
Right. So could you derive an equation from having that information? Based on how you solved the first question I asked. So you said it takes 8. I'm sorry, go ahead.
So washers is equal to...
What are you thinking?
I'm thinking where I will put these two.
Okay.
It's 2 variables. Right? So.
But the variables, what do they mean? They're
I think variables mean just like what you could put there, what number you don't know yet.
So when you think of it in that aspect, how could you write that? Instead of looking at it like, oh, I got so many different variables.
Right. How I would write that?
Right.
But
because eventually you'll know, because in this instance you knew that you had 18 workers, right?
Right.
Okay. So some of the information you will know.
So hours, you don't know hours. So if you're doing a problem, you can either add or subtract to hours. So I guess but I still don't. Okay. But number of watches, you don't know.
Okay. So you went back and you told me that, how did you derive at the answer, your response to 18 workers? Tell me what you did. Write it. Write down
Tell me what I did.
Write the exact steps, what you said. You said.
I said that 36
Mm-hmm.
divided by 2.
Mm-hmm.
You gave me 18.
Right.
So, and then, okay, so, and then you said in 1 hour.
Mm-hmm.
So since it's half the time, I doubled the hour.
Since it's half the workers?
Half the workers, I doubled hours.
Okay.
So I got 2.
Okay. So how would you write that in terms of H&S?
In H&S.
Right.
So would I go hours? So 2 equals...
Based on what you just wrote.
What you mean?
Exactly what you just wrote.
Exactly what I wrote.
Yeah. Go
With
ahead.
the 36.
Exactly what you just said. How would you show that in formula, in an equation form?
But I feel like I need something else in the equation.
Like
but
what?
I'm missing it.
Like what?
Like a variable. But we already have the answers to our variables.
So put the variable in there if you need it.
But we already had the answers to the variable, so it wouldn't be needed.
The answer to the variable, is it really an answer? What exactly does the variable do? What is it doing?
Show that something is equal to it.
It's something else they call it.
It's like an indicator almost.
It's an indicator, right? Okay, so there you go. It represents something. Okay.
You might not know what it is, but it...
So we said we will represent hours with what?
H.
So what hours do you have down in your...
2.
Okay. So let's try to make it based on what you just wrote. Talk it out again. Say it to yourself again.
36 divided by 2 equals 18. And 18, you double the hours from 1 hour to 2 hours. I think I know. What the problem is?
Okay. Well, we won't work hard because I don't want to spend a lot of time on one.
Okay.
But that's good. I mean, you did good this far.
Okay.
So and I'm not going to tell you if you're right or wrong. So don't worry.
Okay.
But again, you're helping us. So that's
right.
the whole process. Okay. So we'll move on to another one. We can use this sheet of paper.
This one?
Yeah.
All right.
Okay. So I want you to fold this piece of paper in half and then open it up.
Hamburger or hot dog?
Whichever way you choose.
Okay.
And how many regions have you made?
2.
Okay. So fold the paper in half again. Now how many regions have you made?
4.
4. And okay, and fold it one more time. Now, without opening the paper, how many regions do you have now?
6.
You have 6?
Mm-hmm.
Okay, now describe to me how you just found the number for your folds.
Because we were doubling everything, so a half, 2 plus 2 is 4, 4 plus 4. Maybe I got that wrong. We just doubling we just putting everything in half, so 2, when you had 1, it turns into 2. When you had 2, it turns into 4. When you had 4, it turns into 6.
Well, we only folded 3 times.
Right.
Right. So you folded once.
Half.
Okay. Then I made you have 2. Mm.
Oh, okay. Now I have 4.
Mm-hmm.
And I have 6.
Now you have 6.
Yeah.
Okay. Okay, now we need your pen and paper back. Can you tell me how you would write, how you would know based on the number of folds? How could you write an equation for what you just said?
These equations. Okay.
Does that bother you?
Yes.
Creating the equation?
The equation.
Okay.
The thing about it, it's very hard for me to create an equation, but I can answer it. It's hard for me to put the variables and the equal sign and answer it on paper, but I can answer it in my head. Okay. I know how to. I don't necessarily put in an equation in my head. I just know.
Okay. Yeah. So what I want you to do is I want you to write down exactly what you said. Again, write it down what you said happened. When you folded the paper the first time, what happened?
One fold equals
two regions. Okay, keep going.
2 folds equals 4 regions. And 3 folds equals 6.
So I'm just curious, if you folded the paper one more time for a fourth fold, how many regions would you have?
8. Ooh, I think I'm wrong.
You think you're wrong?
Mm-hmm.
So evaluate what you've just done.
Okay. The thing... No.
No, what?
That's wrong.
What's wrong?
3 folds.
Okay, so what should it be?
8.
Oh, okay. Don't erase it. Just cross it. Put an X line through it, and then write what you think. So then, if you had 4, how many would you have?
The 4 folds should be 16.
Okay. So now, based on what you've just written, how could you write an equation that would represent that? And then you let R represent the number of regions and F represent the number of folds.
Am I doing it for any particular one?
Nope. It's gonna, for whatever number of folds you put in, you should be able to determine how many regions will come out of it. Okay. So, yeah. So you're gonna let R represent regions and F equal the number of folds.
Regions and F is folds.
Right.
Okay. Read R equals and then the number. Just
So if you plugged in, let's say, your first one, would that be right in your equation? Would that equal the answer that you gave? So if you plugged in those numbers?
1 times 2 equals 2.
Okay. How about the next one?
2 times 2 equals 4. Yeah.
What about the next one?
And equals 3 times 2 equals 6. So I guess I feel like I wasn't right because.
So which one you feel like you were right on?
16's right, but 8. But I feel like we keep on like going half. We keep on like putting stuff in half. So 4 and you double 4, you would get 8. If you double 8, you would get 16.
Okay. But you're doubling the number of what?
Regions, right?
Okay.
Yeah.
And so in this instance, what do you have doubling in your equation?
Number of folds.
But what did you tell me?
The number of regions.
Okay. So based on that, what would you do differently?
I will put the R in a different place.
Okay. So let's see what you will write.
Okay. So R, let's see, equals folds.
So now see if your equation works. Try the last one.
Okay, try this one.
Mm-hmm.
Okay. 16. No. Let's see. What was I said?
Well.
Oh. But I wouldn't know the regions. That's the thing.
Mm-hmm.
We're trying to find the regions.
Mm-hmm.
We're not trying to. We don't know the regions yet. That's
right.
what's the. So R should go right there, but F shouldn't be multiplied by 2.
Okay.
The number.
What don't you know? What don't you know? R was, if you're saying you're solving for R, right?
Mm-hmm.
Is that what you're solving for?
I'm solving for R, yes.
Right. Is that, what don't you know based on that? So you wouldn't know the number of regions, right?
Right.
Okay.
But you would know the number of folds because you'd be folding it once.
Okay. Think about it for a minute.
You start off with one piece of paper, you roll it in half, and you add 2.
So now what are you thinking about?
I'm thinking about how like after 2 the answers were wrong.
Okay.
But like 1 and 2 is self-explanatory. Anything times 1 is the number you multiply by.
Okay.
So it'd be 2.
Mm-hmm.
But 2 times 2 is 4 when you fold the paper in half. So I think it's 8, but I just don't know how to get it.
What do you understand about what you're doing now?
I do understand that folds equal regions, but you don't know. I don't really know what I'm multiplying by. Am I multiplying by about half?
Okay, write that again. Write what you just said. You said folds equals regions.
Folds equals regions.
Okay. Now, what do you mean by that?
The number of folds you do equal how many regions you're going to get out of it.
So are they really equal though? Would you look at that to say that they're really equal? Because
not necessarily, but they're not equal, but that's what they're going to it's going to come out to. How many folds you get is how many regions you're going to receive when you open it.
Okay. I kind of think I understand what you're saying.
So if we do one fold, you're going to get 2 regions. So that's 1 fold equal 2 regions.
Okay.
So you already have 1 fold.
So write that down.
1 fold equals 2 regions.
Okay. Now what would you say for the next one?
So 2 folds. 2 folds will equal 4 regions.
Okay.
Folds. 2 folds equal 4 regions.
Okay.
And 3 folds, this is where it goes downhill. One fold it's such a simple problem, but writing it down is the thing about it. One fold is open it is 2. If you open it, yeah, it'd be 8.
Okay. So be confident in the work you're doing.
Right.
Why aren't you confident?
Because I'm not sure. I'm thinking 2, 4, 6, 8. No. But because we're doubling everything.
Okay.
Maybe we're just doubling itself. So 2 doubled is 4. 4 doubled is 8. 8 doubled is 16.
Okay. So using R and F, how would you show that in an equation form?
This would be an equation without the folds, really. But F equal R.
Mm-hmm.
But I don't know, would you put, is the R itself supposed to equal is R itself is supposed to equal the number, or is the number supposed to be before the variable? Like 2 regions, like 2R, or is R like R, like if you see equation,
Mm-hmm.
it has to go inside
The parentheses?
right, like the number, or is it supposed to be like 2R?
So if you say 2R, you're saying like 2R equals F?
Yeah.
So then how would you solve for R if you did that?
Divide both sides by 2.
Okay. And then R would equal what at that point?
Nothing. 2 divided is, it'd be 1. But you don't write 1s in front of variables. So it would be R equals, the answer, I guess it'd be R equals 1/2. Because the 2R equals 1 fold. If you divide both sides by 2, you would get 1/2 on that side. You get what I'm saying?
Mm-hmm. Okay.
I feel like I'm doing one thing wrong. One simple thing.
Okay. Well, that's good. That's good work. We'll stop at that problem right there because I think you've done well going that far.
Okay.
I just think it's something you're not quite connecting. Help me again understand. How did you come up with this? What made sense to you when you folded the paper once?
It just made sense that everything was doubling.
Okay.
It just made 1, and then 2, 4, and then 4, 8. If you put in 8, you're not really putting 8.5 because the paper isn't going anywhere. So you're really just doubling that 4 as you keep on going in halves. So you're just splitting things up.
So when you look at the numbers the number of regions that you created once you fold the paper, tell me, when you're looking at those numbers, is there something about those numbers that scream out to you? Do you see something in the numbers other than them doubling? Do you see something else?
No, I don't. I see it's almost a pattern.
Okay.
But the pattern is still doubling. 2 plus 2 is 4, 4 plus 8, 4 is 16.
Okay. Okay. Well, we'll move on to the next one.
Okay.
Okay. So let's try this problem. It's called it's a refund. So in some states, a deposit is charged on aluminum pop cans and is refunded when the cans are returned. Sorry. In New York, the deposit is 5 cents a can. What will be the refund for returning 6 cans?
5 cents. It's 5 cents again? For 1 can.
Right. And so what would you get for returning 6 cans?
30 cents.
30 cents? Okay. And what about 10?
10 cans, you get 50 cents.
Okay.
Yeah.
Now, so again, we're at this point where you need to tell the manager how would they be able to determine the refund based on the number of cans returned. What would you say to them?
I say that to explain it in words, 5 cents equals 1 can. So you just multiply how many cans by the number of each can, you'll get the answer of how much the refund would be.
Okay. So you're multiplying the number of cans returned by
the number of money you refunded is for 1 can.
Okay.
Yeah.
Okay. Which is the
5 cents.
Okay. All right. So now here we go with this, your favorite part.
Yeah.
So let R represent the refund, and C equals the number of cans.
Okay.
So how would you write the equation for the manager to show what they could use to figure out what the refund would be?
Okay, think about this. So what was the first thing that you multiplied it with? That number of cans it was?
10.
The first
6
one?
was, I'm
six.
sorry, 6.
Was 6? Okay.
Mm-hmm.
The refund was $30 equals 5 times 6, which is 5 times the cans. 5 times the number of cans. It's pretty much how I did it. Oh, but
So using the letters, what would you write? How would you write that as?
R equals C. No, that's. Let's write that over again. R equals times C. So number of cans times 3, and it'll equal your refund.
So if using that formula, would they be confused about how much to give them back? Because it's 5 what?
Cents.
Does your equation represent that?
No.
Okay.
But you wouldn't put cent in a equation. That's the thing.
You wouldn't?
No.
How would you write 5 cents? How is 5 cent represented?
Oh, Duh.
Don't erase it.
Okay. 0.05 times cans.
Okay. So now that you have your equation, can you find out how many cans will need to be returned if the refund was $3? Using your formula. So if the refund amount was $3, how many cans were returned?
The refund was $3. And the cans are that, and then you're trying to find a number of cans. You trying to find a number of cans? So we have to multiply.
Looking at what you wrote down, does that mirror your equation that you wrote?
Almost. Almost.
Almost?
Because I'm missing something.
What are you missing?
Cans.
So
It'd be C.
And so how would you work that?
But it doesn't seem right. Because usually if I have a problem like this, I subtract 0.05 from $3, and $3 equals C, and C will be the number of cans you have.
You would subtract?
Yeah.
Why would you subtract?
Because it's already a positive number.
It's a positive number?
Yes.
Okay.
So if it was a negative number, I would add.
It was a negative number.
Yeah, I would add.
So if you're adding and subtracting, wouldn't you be adding and subtracting?
Say that one more time.
I said, if you're adding and subtracting from each side, wouldn't your problem have to have addition and subtraction in it?
Yeah.
So what does your problem have in it?
Multiplication.
Oh, okay.
Yeah.
And how do you undo multiplication?
Division.
Okay. So then how would you solve your problem? What kind of problem is your equation?
What kind of problem?
Yeah. What operations are you using? Read your equation to me.
$3 equals 5 cents times C.
Okay. Oh.
Okay. And then after that's crossed out, because that's unneeded anymore, you'll have $3 divided by 0.5 equals C. But then you have to figure that out first. So 5 cents is $3 only. So 20 cents is $1. So 25 cents is $1. So 60. So 60 of 5 cents would be $3.
Okay. So how would you write that down? Write it down so I can see how you solved it. Okay. Show me the math on the paper.
Okay.
Okay.
We'll discuss that.
Don't? Okay.
I just crossed it out.
Okay, so we've reached our 45 minutes. Kind of went fast.
Yeah.
I know. So, what do you think was challenging about the problems?
Writing the problems?
Or any of the problems? Do you think one problem was more challenging than the other?
The washers was kind of like not really challenging, but kind of challenging because I didn't know how to write an equation. I kind of knew how to answer it in my head because it's not really mathematics that I'm doing. Doing is like logic. On what I'm trying to like get to. Because like my answers, I feel like they're logical. Like if you have 5 cans, I mean if 5 cents equal 1 can, so and you multiply the 5 cents by 6 cans that you have, then you should get a 30-cent refund. It's just logic. It's not. I don't really take it as math.
So did you find one to be easier than the other?
This one was pretty easy. Maybe not writing the equation, but that one was pretty easy. The folds one was kind of difficult. Yeah, it was.
So none of them were easy?
This one was easy. Yeah,
the refund was easy.
Yeah.
All right. Well, we're on a close here. Thank you again for helping future teachers.